Hello, everyone. Thanks for joining. We'll go ahead and get started in just a few seconds while people enter the webinar. All right. So thanks for joining today, Enhancing Medical Coding with AI and LLMs webinar. My name is Jordan Leibovitz. I'm part of the marketing team here at IMO Health. I'm happy to announce that this webinar has been approved for CEUs by AHIMA. So the recording and a certificate of attendance will be sent to your email later this week. So check your inbox. If you have any questions throughout the webinar, put your questions in the questions section on your Zoom webinar console. Once our speakers wrap up, we'll do Q&A. Today we have two lovely speakers from IMO Health, Dr. Vidya Sivakumaran, and she's the VP of Clinical Informatics and Terminology Data Engineering, the mouthful of the title, and then Dr. Dinkyu Wang. He is our SVP of Data Science and Chief AI Architect. With all of this being said, I'm going to pass it over on to Vidya.
Thanks, Jory. So welcome, everyone. As our host mentioned, my name is Dr. Vidya Sivakumaran, and I am the Vice President of Clinical Informatics and Terminology Data Engineering here at IMO Health. Before we get into the actual meat of our presentation, I'd like to introduce you to IMO Health, a company that has been at the vanguard of clinical terminology for nearly 30 years. Founded in 1994, IMO Health has established itself as a leader in healthcare data management. Our mission is focused on ensuring clinical data quality, usability, and value across the entire healthcare ecosystem. From documentation at the point of care to complex approaches for population health management, IMO Health Solutions enable data-driven insights that healthcare professionals can trust. Let me share some really cool facts that demonstrate our reach. Our solutions are used daily by 740,000 U.S. healthcare professionals across 4,500 hospitals nationwide. We manage over 5 million terms and map them to all major coding systems, creating a comprehensive clinical vocabulary framework. Behind this work is a team of approximately 300 full-time employees, including physicians, terminologists, PhD-level healthcare informaticists, and former hospital CIOs and CMIOs who bring deep clinical expertise to our solutions. So with that being said, let's discuss why our work matters. Healthcare today faces a significant problem that affects everything from clinical care to administrative decisions. That challenge begins at the point of care, where data capture is cumbersome for clinicians working with various electronic health record systems. Many providers struggle with documentation burdens that take time away from patient care. As this data moves through the system, aggregation introduces critical gaps and inconsistencies. Information collected in different formats or using different terminologies become difficult to reconcile, creating silos and preventing a complete picture of patient health. The end result, bad data leads to uninformed decisions that then affect patient outcomes, resource allocation, and healthcare costs. Underlying all of these challenges is a complex web of terminology and codes. As you can see in our illustration, healthcare data flows through multiple coding systems, from SNOMED to ICD-10-CM to CPT, HCPCS, LOINC, and RxNorm, and obviously much more. Each system serves a specific purpose, but together they create a maze that healthcare data must navigate. IMO Health Solutions address these challenges by standardizing terminology and mapping between these different coding systems, creating a more seamless flow of accurate clinical information throughout the healthcare ecosystem. So this begs the question, why medical coding is so critical to healthcare operations. Medical coding might seem like a purely administrative function, but its impact reaches every corner of the healthcare ecosystem. First and foremost, accurate coding ensures proper reimbursement. When providers document and code correctly, they receive appropriate payment for services rendered, maintaining the financial health of healthcare organizations. Beyond financial considerations, coding supports clinical decision-making, and well-structured coding data helps clinicians identify patterns, track outcomes, and implement evidence-based practices that improve patient care. Proper coding also enhances compliance and reduces risk. Healthcare is heavily regulated, And accurate coding helps organizations meet legal and regulatory requirements, avoiding penalties and audits that can be costly and disruptive. The value of coding also extends to research and analytics. Standardized codes enable researchers to analyze large data sets, identify trends, and advance medical knowledge to ultimately benefit patients. For quality reporting and HCC risk adjustments, coding provides the foundation for measuring performance and risk stratifying patient populations, which is essential for value-based care models. And finally, coding facilitates interoperability and data exchange. When different systems speak the same coding language, information can flow seamlessly across the healthcare continuum, supporting care coordination and comprehensive patient management. So, as we move into more of the presentation, let's talk a little bit about key challenges in medical coding. Despite its importance, medical coding faces significant challenges that can impede its effectiveness. These challenges fall into several key categories. First, there's documentation complexity. Many clinical notes are incomplete or ambiguous, making accurate coding difficult. Physicians also vary greatly in their terminology and documentation style, creating inconsistency. And the growing volume of data in EHRs, often in cut and paste format or checkboxes, further complicates the coder's job. The regulatory burden is another major challenge. Coding systems like ICD-10, CPT, or HCPCS undergo frequent updates that coders must master. Payer-specific requirements and guidelines create a maze of rules that vary by region or insurer. And with strict compliance standards carrying significant penalty risks, the pressure on coding teams is intense. There are also operational hurdles that we need to think about that compound these changes. Many facilities face coder shortages and high turnover rates in this very specialized role. Backlogs in coding lead to delayed reimbursement, affecting cash flow, and productivity pressures can push coders to sacrifice accuracy for speed. Technical limitations also create barriers. Legacy systems often have poor interoperability, making it difficult to share coding data. And some of these traditional coding workflows have limited automation, relying heavily on manual processes. So integrating coding tools with existing EHRs remains challenging for some organizations. All of these challenges have direct financial impact. Revenue leakage from undercoding means facilities aren't being paid for the services they provide. Denials and audits, on the other hand, related to imprecise coding, create administrative headaches and financial losses. And organizations constantly struggle with the trade-off between coding speed and accuracy. As we move forward in our presentation, we'll explore how IMO Health Solutions address these challenges to unlock the full potential of medical coding. So before we get into some of that, let's examine the most common errors that we might encounter in medical coding that impact the healthcare organization, both clinically and financially. One of the most frequent issues is undercoding, where services provided are not fully captured in the code submitted. This directly impacts revenue and underrepresents the complexity of care being delivered. At the opposite end, we have upcoding, which involves using codes that reflect a higher level of service than what was actually documented, a practice that can trigger compliance penalties. Specificity errors can appear frequently. Not coding to the highest level of specificity means using general codes when more specific ones are available. For example, using a general diabetes code instead of a type 1 diabetes with specific complications. This impacts reimbursement and clinical data quality. Modifier usage presents another common challenge. Incorrect application of modifiers, those that provide additional information about procedures, can also lead to denials or improper payments. These small details make a difference in how claims are processed. And then, of course, there's documentation issues, as I mentioned previously, which are represented in several ways. Incomplete records, insufficient or poor quality data, like think about a missing op note or something like that, could lead to missing significant information needed for accurate coding. Unbundling errors occur when separate codes are used for procedures that should be billed together under a single comprehensive code. This practice, whether intentional or accidental, can be flagged as an attempt to increase reimbursement. And then not adhering to NCCI edits, that's the National Correct Coding Initiative, means ignoring the rules that define which procedure codes can be built together, resulting in denials and compliance issues. Each of these errors creates different risks: financial risks from loss in revenue, or audit penalties, clinical risks from inaccurate patient records, and operational risks from delayed payments and increased administrative burden. So now that we've talked a little bit about medical coding and its importance and some of the common errors, let's explore how artificial intelligence is transforming this space. Healthcare IT is forecasted to grow at a compound annual growth rate of 49.1%, which is really staggering if you think about it. That really reflects how quickly organizations are trying to adopt these technologies to address these critical challenges. This growth is being driven by several key factors. First, we're facing a significant coder shortage with a 30% gap between the demand for qualified coders and their availability. This workforce challenge is creating an urgent need for technological solutions. Looking at the current landscape, we can see that healthcare organizations are already responding to these pressures. 74% of large healthcare systems are now implementing or researching and developing some form of revenue cycle automation to address coding inefficiencies and staffing challenges. We're also witnessing an evolution in the technology itself. What began as simple computer-assisted coding is rapidly developing into AI-driven solutions that can understand context, learn from patterns, and make increasingly sophisticated coding recommendations. On the market side, several factors are accelerating this adoption. Documentation complexity continues to rise, particularly due to value-based care requirements that demand more detailed and specific coding. Additionally, there's increasing pressure for real-time coding and billing to improve cash flow and financial performance. These combined factors are creating the perfect conditions for AI to move from a nice-to-have technology to an essential component of modern medical coding operations. Continuing on that trend, this slide is meant to illustrate the journey of medical coding technology and where we're headed in the coming years. So we're seeing a clear progression through maybe 4 stages. First, the traditional manual coding, which has been the standard for decades. Second, computer-assisted coding, which provides basic automation, but still requires significant human oversight. And third, AI augmented coding, which is where we are now, where artificial intelligence works alongside human coders to enhance productivity and accuracy, or at least this is where we're seeing people are starting to move. And finally, the emerging frontier of autonomous AI systems that can handle routine coding with minimal human intervention, which is very much a future state. Several key trends are driving this evolution. We're seeing increased automation of routine coding tasks, enhanced accuracy through predictive analytics, and that can suggest the most appropriate codes. And of course, natural language processing that can interpret clinical notes, advanced auditing and compliance tools that catch errors before submission, and specialized tools designed specifically for coders to boost their productivity. The benefits of this technological transformation are substantial. Organizations implementing AI augmented coding will report in the future significant reductions in coding time, enhanced compliance and audit readiness, reduced administrative burden on clinical staff, and fewer claims denials and coding errors. As we look to the future, we anticipate AI augmented coding becoming standard practice across healthcare, a shift from a retrospective to real-time coding perspective that accelerates the revenue cycle, and deeper integration with clinical decision support systems to enhance both financial and clinical outcomes. Now, I want to emphasize that this evolution isn't about replacing human coders, but rather augmenting their capabilities and allowing them to focus on the most complex cases that require human judgment and expertise. So as we move into the next slide, JQ, will you take us away here about how far LLMs can go in medical coding?
Yeah, sure. Thanks, Vidya. Hi, everyone. My name is Jinqi Wang, SVP of Data Science, Chief AI Architect at the IMO here. I'm leading the team for the hands-on large language model, natural language processing, development work. Part of my job here is make AI easier for everyone. Let's start with my name, so you can call me JQ. We've been monitoring on the progress of large language model on this medical coding domain. Like Vidya pointed out, AI have great potentials in medical coding, but we have to implement AI in the right way. So intuitively, everyone can ask a question to GPT, to large language model, hey, what's the ICD-10 code for this term, right? So anyway, they give an answer, but is that the correct answer or not? We've been monitor on this out-box capability of LLMs. I think as early as 2023. At that time, some of these early open source models, some of the early version of GPT models, we all evaluate that and ask the question, what's the ICD-10 code for this term? Our observation is that early stage, like the Llama version or the early version of the GPT-4, they don't have good understanding of the ICD-10 codes. They give like for example, the Llama 2, they give like a zero cracker code. They understand ICD-10 is a combination of letter and then digits, but then now the code is correct. Then with the development of large language models, we can see the outbox accuracy improved over time. And the most recent evaluation on the GPT-4o1 model, that's a model with all these problem-solving logic. We can see the outbox accuracy can reach like a 64 something on the ICD-10 code understanding. That seems a decent number, but is that really good or practical enough for macro coding usage? And then based on our observation on all the results, especially the error analysis, I think it's still like not that practical enough for macro coding usage. And then especially there are still quite a lot of hallucination there. Or may give like a fake code. They give like a very unspecific code. They give some mismatched code or terms. So next slide, we can see more examples on these coding errors. Next slide. Yeah. Yeah. Those are some common errors. Just use LLM out of the box without any further enhancement. Sometimes they miss like a contextual understanding. Sometimes they give like a hallucinations, really wrong code. That's not even a real ICD-10 code. Sometimes they have those specificity problem. They give more, for example, just 3 digits. It lost all these fine granularity information there. And there are other issues like that, compliance, and then other issues. Vidya, you have one example for this macro errors?
Yeah, so if you think about like a contextual misinterpretation around family history, so a patient's family history might mention something like the father had type 2 diabetes. And you could see like an LLM could mistakenly code the patient as having type 2 diabetes instead of recognizing that as a family history issue. Or yeah, or in the incorrect code generation, a provider might document a patient with chronic kidney disease, stage 3 and hypertension. And what could accidentally happen is it could assign a 10 cm code for hypertensive heart disease with CKD, which is a different clinical criteria coding wise, instead of the essential hypertension with CKD stage 3. So you can see kind of where it could kind of interpret that piece.
Yep. And then I think we are not the only team evaluating the outbox LLMs. There are other academic research and then scientific publications on the LLM as a macro coder. So next slide. There are some study from a group of researcher from the Mount Sinai Health System. So they did the really thorough analysis on these 27,000 unique diagnoses and then procedures, send them all to large language model, different LLMs, including like a GPT-4, GPT 3.5, some of the other open source LLMs. The finding is consistent with our observations. So out of the box, LLM shows some level of understanding on ICD-9 code, ICD-10 CM code, CPT code, but still, no, without the additional enhancement, that's not practical enough for real use. And then next one is their recommendation. So in the conclusion side, LLMs are not appropriate for use on medical coding tasks without additional research. And then I think that's consistent with the observation, but the open question is how about the with additional research, right? Then we start to explore like how to enhance the outbox LLM with the content that we have and all the other proven AI technologies. We'll introduce our practice, how to enhance this outbox LLM in the following slides. But before that, we are just very curious about how many of you using AI today in your workflows. Maybe Jory, can you pull out the poll questions?
Thanks, Q. All right, so if everyone could answer the simple question, do you use AI in your current workflow? I know I sure do. All right, we'll go ahead and end. So it's kind of even. It's about 48 to 52%. So interesting.
Yeah.
Interesting.
Good.
I expected higher numbers.
Yeah, me too. All right, you can go ahead and Q.
Sure. I think next we'll introduce the IMO content and then also our AI technologies, how to combine the LLM with the IMO content strength. That will start from the detailed introduction about our terminologies, Vidya.
Yeah. So as we move into the benefits of IMO Health terminology, I guess the question there is, so what's our solution to this LLM problem? Obviously, IMO Health clinical terminology, which is why we're all here today. What sets us apart is that 30-year foundation I mentioned of expertise in clinical terminology. This is something we've not recently developed in response to the market. It's been our core focus for 3 decades. Our terminology encompasses thousands of pages of carefully curated editorial content, specifically designed to translate complex medical language into precise standard terms. This precision is crucial because it dramatically reduces ambiguity in code selection, which directly impacts that accuracy and reimbursement we've been talking about. To give you a sense of scale, our comprehensive coverage includes over 1 million unique concepts and 5 million descriptions. That's an extraordinary breadth of medical terminology out at your fingertips. And the adoption speaks for itself. Our solution is currently used by 89% of US physicians, nurses, and physician assistants. One of the key strengths, though, of our terminology is specifically that it encompasses all industry standard terminologies that matter in healthcare today. So ICD-10-CM, IC9-CM, SNOMED, CPT, HCPCS, LOINC, and so much more. This integration is vital for seamless workflows across different coding requirements. And I guess perhaps most importantly, we talked a lot about this fragmented healthcare landscape. Our solution actually ensures that consistent interpretation across the different healthcare settings, from small private practices to large hospital systems, outpatient facilities, and to specialized care centers. Behind that solution are several exceptional teams across our company, but most notably our clinical informatics team and our mapping team, which brings together over 150 years of combined clinical informatics expertise and over 136 years of health information experience. Their depth of knowledge ensures our terminology remains clinically accurate, comprehensive, and aligned with evolving medical practices. So when we talk about enhancing LLM performance in medical coding, this robust terminology foundation is precisely what makes that difference between acceptable results and exceptional accuracy. So let's take a look at specifically what makes IMO Health terminology superior in the marketplace, especially when we compare it to other alternatives like UMLS. First, our terminology contains 20% more synonyms per concept than UMLS. This is crucial because it means we better capture the various ways clinicians like to describe things and like the same medical concepts in real-world practice. When a physician uses alternative phrasing or specialized terminology, our system is significantly more likely to recognize and correctly map it. Secondly, we maintain a higher percentage of long and complex terms. This is not just a technical distinction, it's fundamental to that accuracy we've been talking about. Complex medical conditions and procedures are often described with nuanced, multi-word phrases that carry precise clinical meaning. Our terminology preserves this complexity rather than oversimplifying it, which directly translates to more accurate coding, meaning we're much more granular. This graph you see here visually demonstrates that difference. Looking at the distribution of term lengths, you can see the purple bars representing, or the darker purple bars, I should say, representing IMO's terminology, and that it contains a significantly higher percentage of longer, more descriptive terms compared to UMLS. And this is based on an analysis of over 2 million clinical notes, where we found 50% more of IMO Health terms compared to UMLS terms. A clear indication that our terminology better reflects how clinicians actually document care. When we integrate that terminology with LLMs for medical coding, we're building the strongest possible foundation for accuracy and completeness. So, addressing the central question that we're all here asking, can large language models truly excel at medical coding? Our answer is a confident yes, but with an important qualification. LLMs can achieve this performance, but only when powered by rich semantics, which is powered by IMO Health terminology, and specialized clinical AI. What you're seeing on this slide represents the essential formula for success. It's the combination of two critical components. On the left-hand side of the slide, we have deep clinical ontologies and informatics, the foundation that we've built IMO on over decades. This includes widely adopted and comprehensive terminology that spans the full spectrum of the medical practice. Our accurate and up-to-date content curation ensures that terminology reflects current medical understanding and coding requirements. We provide well-documented guidelines and instructions that offer clear pathways for implementation. And crucially, we bring decades of access to clinical data that has informed and refined our approach. On the other side of this equation are the proven AI methods and techniques that transform the foundation into powerful coding solutions. We've developed advanced prompt engineering specifically optimized for medical coding challenges. Our retrieval augmented generation capabilities also ensure the LLM draws on the most relevant and accurate information. And we've implemented AI agents and external tool calls that extend the model's capabilities beyond the inherent limitations. And perhaps most importantly, we fine-tune open LLMs with IMO content to dramatically improve that performance with for medical coding tasks. It's this powerful combination and that plus sign in the middle that makes the difference between basic LLM performance and exceptional medical coding capabilities. So neither component alone is sufficient. Generic LLMs without specialized medical knowledge fall short on accuracy, while even the best medical knowledge base requires sophisticated AI techniques to be applied effectively in coding scenarios, like the ones you've seen in previous slides. This approach represents IMO clinical AI, our answer to complex challenges of medical coding in the era of artificial intelligence. So, sorry, my slide's not moving. Okay, so before we get into the LLM pieces and the AI augmented pieces, let me walk you through the structure of an ICD-10-CM code and why understanding its structure is so critical to what we do at IMO Health. What you see here is a breakdown of an ICD-10-CM code, S86.011D. This represents strain of right Achilles tendon subsequent encounter. Each character in this code serves a specific purpose and adds a layer of clinical precision. The first three characters in this case, S86, form the general classification. This tells us we're dealing with an injury of the muscle, the fascia, and tendon at the lower leg level. Characters 4 and 5 add significant specificity about the location, type, and severity. Here, .01 specifies that this isn't just any lower leg injury, but more specifically a strain of the Achilles tendon. And the sixth character adds further clinical detail. In this particular example, the 1 indicates that it's the right Achilles tendon, not the left. So finally, that seventh character, D, provides information about the encounter type and healing status, showing that this is a subsequent encounter, not the initial treatment. So why does this level of detail matter? For 3 critical reasons, and those are shown at the bottom of the slide. First, specificity. These detailed characters provide granular details about the medical condition that are essential for proper treatment. Second, accuracy, which precise coding ensures accurate patient records and treatment tracking, which directly impacts the quality of care. And third, reimbursement. Detailed codes support faster and more accurate medical claims, which affects the financial health of the practice or healthcare system. This is precisely where IMO Health terminology expertise becomes invaluable. Our clinical terminology system is designed to seamlessly map the language physicians actually use in their notes to these highly specific ICD-10-CM codes. When a physician writes injury of right Achilles tendon follow-up visit, our system understands the clinical concepts and relationships needed to generate the exact code. The complexity you see in this single code multiplied across tens of thousands of possible codes is why medical coding requires both deep clinical knowledge and advanced technology. The exact combination IMO Health provides through our clinical terminology and our AI solutions. Now I'd like to show you how IMO's terminology serves as a critical bridge between clinical language and financial risk scoring, a connection that has significant implications for healthcare organizations. So looking at this diagram, you can see the essential language we provide across three key domains. On the left, we have IMO terminology, the language clinicians actually use in their documentation. The middle column shows the corresponding ICD-10-CM codes, and the right column displays the CMS hierarchical condition category, or HCC codes that are associated and their risk weights. So walking through this example, when a physician documents type 2 diabetes mellitus with nephropathy, IMO terminology maps this to a precise ICD-10-CM code E11.21, which then corresponds to an HCC 37 with a risk weight of 0.166. And this is similar for the other examples on the slide. These risk weights directly impact reimbursement and risk adjustment calculations, making accurate mapping absolutely essential. The benefits of this bridging function are outlined at the bottom of the slide. First, it enables comprehensive clinical documentation that ensures medical records provide a complete picture of a patient's health status, going beyond that surface level of the diagnosis coding. Second, it increases specificity and accuracy by demanding granular details about the patient's conditions, encouraging documentation of nuanced clinical information, and reducing ambiguity. And third, it enables powerful AI use cases, including enhanced HCC documentation, clinical decision support, population health management, and enhancements to natural language processing. And finally, and perhaps most importantly for operational efficiency, it eliminates the need for manual HCC assignment, which is time-consuming, error-prone, and expensive. This bridging capability demonstrates how IMO's terminology isn't just a clinical tool, it's a critical financial and operational asset that directly impacts revenue cycle management and risk adjustments. So there's one more thing that I wanted to actually highlight about IMO's terminology. So turning our attention to the critical aspect of medical coding that's often overlooked but has enormous impact on both patient care and reimbursements, secondary codes. As you can see at the top of the slide, secondary codes provide essential context beyond the primary diagnosis, significantly enhancing risk adjustment accuracy. By capturing comorbidity, complications, and additional health factors, they enable more nuanced and precise healthcare risk assessment and management. So looking at the left column, we have a patient with documented diagnoses, including chronic diastolic congestive heart failure as the principal diagnosis, along with COPD, CKD, and hypertension, as well as class 3 obesity. Each of these conditions has its own ICD-10 code, CMS HCC category, and associated risk weight. So what's powerful about what IMO Health's approach is shown in that middle column. Our system doesn't just passively accept the documented diagnosis as is, it actively suggests additional clinically relevant codes based on the relationships between these conditions. For example, when seeing a constellation of diagnoses, our system suggests hypertensive heart disease and renal disease with renal failure, stage 1 through stage 4, or unsuspected chronic kidney disease with heart failure, a much more specific and comprehensive code that more accurately captures the patient's true clinical picture. The impact of this is quantified in the insights column on the right. We see the risk complexity increase to 0.632 from these secondary codes, a substantial financial impact for healthcare organizations. So our terminology includes both primary and secondary coding, along with combination codes or cross-reference to multiple terminologies. Most importantly, as highlighted at the bottom of the insight section, IMO captures these detailed semantic differences between medical codes, providing a more comprehensive and precise coding output. This capability addresses one of the key limitations we saw in the previous slides about foundational LLMs, their inability to handle complex conditions requiring multiple codes. By incorporating IMO Health clinical terminology and AI approaches, we can overcome this limitation and ensure accurate, comprehensive coding that reflects the full clinical picture while maximizing appropriate reimbursement. And so on this next slide, Jing-Chi will talk to you about why foundational LLMs fall short.
Yeah. So from this slides, we show some example, like when you have an input, and then some of the outbox LLM, they just give you 3 digits result. For example, you put this is type 1 diabetes with something, and then the LLM just give you E10, 3 digits there. That's not a wrong code, but that's just not specific enough. The value is not there. So with the IMO's content, we want to, and then a design goal for the IMO clinical AI enhanced microcoding solution. We're not stopping at the a 3 digits category level. We want to find and then return the most specific ones. And then with these high HCC values as shown in this example. And then on the left side, you see those most specific codes, multi-digits. That's some limitations from the outbox LLM. And then next, there will be some tech details how we implement the IMO clinical AI on top of the general domain LLM and also the IMO terminology content. The first technology we are using in this implementation is prompt engineering. Next step. So in the prompt engineering, I think maybe lots of you are already familiar with the term prompt engineering there. So in prompt engineering, we can do so much more than simply ask a question to LLM, hey, what's the ICD-10 code, right? In the prompt engineering, we can define what's the goal, what's the definition of this problem, and then some specific instructions how to solve this problem, and then define what's the output format of the LLM's output, what's the specific coding guidelines there. We have internally all these accumulated IMO editorial rules, some of these specific coding rules. And also there's a place in the prompt engineering that we can provide examples there, both positive example, negative example, both like an inclusion example, exclusion example, then with all the input sent there. So with all these very detailed instruction, we kind of constrain the LLM's problem-solving logic to our predefined logic, very specific to the problem we're trying to solve. And then all the domain knowledge, medical-related domain knowledge will be there in the form of the prompt engineering. And that's very helpful for LLM to break down this problem, solve this problem. This prompt engineering, usually that's like a very close collaboration between medical SMEs and the AI engineer. They work together to optimize this prompt, find the most helpful, most effective format and the content for this prompt engineering. And the next technology is the retrieval augmented generation. So in the retrieve augment generation, we are not asking Gen AI or LLM, hey, just generate a code. But instead, we provide a list of these possible code, related code. And then all those may be like a related with my query. And all those candidates are actually built on top of the solid foundation of IMO terminology. All those are real code. All those are the terms the physician using in their workflow. So we provide the top 10, top 20 for to consider, right? Select from the list we provide, do not generate the things. So this is a fundamental way how to reduce the hallucinations from LLM. We don't expect LLM to generate a code, but just simply select from the candidates we provide here. And then when LLM make the selection, that's also the place where the prompt engineering can be optimized. We can define a lot of criteria, what's the possible code, what's the most accurate code in this problem. As you can see in this example, we are input one procedure, and then from the IMO procedure domain terminologies, we get a list of those IMO concept ID and then possible IMO terms there. Then step 3, we send all the input, then our instruction how to select and all these possible codes into LLM. Eventually, LLM make a selection there. That's one IMO concept ID. And using that IMO concept ID as a bridge, we can find the two possible CPT code here. So all those results will be returned for microcoder to consider. Then the next type of technology is called the AI agents. That's also very popular now, especially this year. So this is one step further. So in addition to LLM simply make a selection, we can ask LLM, hey, try to think about how to query, think about how to solve this problem, right? As an example in here, whenever we have input, say impair the total range of motion, that's an input. And then through prompt engineering and other AI agents implementation techniques, we can enable the LM try to, find some other synonyms, right? Or try to find another better query. I think it's more accurate to find the accurate code. So in this example, I almost start to think, okay, I got this input, but I also want to try something else because I think that's a synonym. Maybe that's a better query. So I'm start to query those two on IMO terminologies and then get some candidates there and start to check on these candidates. And then unfortunately, now the two queries have a really high enough confidence score. The first column of the return result is the confidence score. So I'm gonna find out probably still no good match. But I do notice another word that's a stiffness, right, from the return result there. So LM start to try the second round. And this round, I update the query and then use the keyword stiffness there and then run the query again. This time, find like a very good matching. That's 1.0, very confident matching result. And then based on that, step 3, start to make conclusions. Say based on all the effort, I try different queries, I retrieve and then examine all the code returned, and then based on all the coding guidelines in the prompt engineering, I can make the final decision on recommendations. So that's the code, that's the title, this code, and that's how I make this selection. So with this AI agent, then the solution is not like a black box anymore. You can literally see how I'm trying to solve this problem. And then the next type of technology, we implementing this fine-tuning capabilities. So all the previous steps we can implement that using the general domain LLM. We can use the GPT-4 to trigger that. We can use like an anthropic model to trigger that. And one additional thing we're doing right now is like teaching of general domain LLM with all the IMO terminology and the IMO content. Like video showed that we have all these concept IDs, terminology codes, synonyms to the same concept, and then have these broader, narrower relations across the different macro concept. Then we have some of our like IP data, product logs. All those are good resource to make the general domain LLM smarter to the IMO specific use case. So the goal of this fine tuning will be further enhance the general domain LLM with our own data. Then this enhanced version of LLM, we expect that have a better chain of thought, better capability solving the macro mapping problems. And then next one is one example. This is what we have in the IMO Studio. And then if we try some query there, input the term, then we'll return the result in the form of IMO code and also the title, ICD-10 code, ICD-10 title, and also like a reason why this code is selected. So a lot of our SMEs find those explanation is very helpful to understand this solution is a trustworthy AI enhanced solution. And then, right. So additionally, like Vidya pointed out, behind the IMO concept, we have those preferred primary code, preferred secondary code. So we have like a preferred primary code here, and also we have the preferred secondary code to enhance the downstream applications. Right. So in conclusion, the IMO clinical AI enhanced solution, we have the improved mapping accuracy compared to our box, which is at like a 40, 50 level with the IMO terminology enhanced version and then also the clinical AI enhanced version. Same data set, we can almost double the mapping accuracies to macro code. And then additionally, using generalizability capability of LLMs, we are not only return the code, but return the reason why this code is selected. And third, by leveraging IMO as a bridge here, we are linking not only like one single ICD code, but have those preferred secondary code and also other industry level terminologies and also HCC, so much more through IMO as a bridge. And some key takeaways for this presentation. I think first we want to highlight that the out-box LLM, it's still not good enough for medical coding without the additional enhancement. And then in IMO, we have those next domain terminology resource accumulated, curated many, many years, very solid foundation of truth to enhance the LLM medical coding solutions. And then by leveraging combine like the IMO terminology resource with the generalizability of public domain or fine-tune LLMs, then we can set a new standard for this automatic medical coding. Vidya, anything else you want to highlight?
Just highlighting that, the 30 years of rich semantics that we have is really the foundation of a lot of what we do at IMO and specifically these AI solutions that we're working on.
Yeah.
Great. So I think, Jordan, I guess we're ready for some Q&A.
Yeah, perfect. All right, so if you have any questions, just type them into that Q&A box. We do have a few that came in already. One of them being, is there a way to evaluate the tool for accuracy after implementation?
Yeah, I can start on that. So usually for this kind of evaluation, we'll create some manual curated data set, maybe pull some of these diagnosis terms and then have microcoders review that, have the recommended microcode there as what we call the gold standard. And then we run this automatic solution on that, compare the system prediction versus the manual review result from microcoders. And then we can calculate some of these numeric evaluation criteria, like usually it's precision, recall, F1 scores. Those are pretty standard in this evaluations.
Great. And then how often is the LLM updated within your system, within the application?
Yeah, I'll say that depends because we all know that LLM almost new version of a different kind of LLM coming out every month. So we'll try our internal evaluation on that. Some criteria on this evaluation, including like clinical qualities of that LLM, how the LLM understand or follow all the instructions of our prompt engineering. And we'll also evaluate from the cost and operational efficiency perspective, does that good enough for large scale usage? And then based on all these evaluation criteria, we may have some of these foundation models options available. depending on different use case, then we can choose which kind of foundation LLM we use in that use case. If some use case emphasize like a really high clinical quality, we'll recommend using these like expensive ones simply just because they have like a better prediction, better qualities. For some use case, they run like a billions of clinical notes. Then we'll recommend the cost-effective ones, decent accuracy, but a much balanced cost in that scenario. So we'll keep monitoring all these possibilities.
Got it. Okay, just curious if you ran reports, whether real audits or mock audits, on accuracy versus actual codes approval and reimbursement, and has the rate increased over time as you worked on enhancements and improved internal fluency of your tools?
I'm just reading it myself. We've done a lot of internal mock work, at least on my side, alongside Jing Qi's team. And so not specifically approvals, but around code accuracy. And we're continuing to do that on a pretty regular basis. We have multiple people in our teams working to improve the LLMs and improve accuracy, but we are seeing improvement as we continue to fine-tune the prompts and the RAG operations that we have.
This tool looks really impressive. One observation, although, is that in the ambulatory settings, providers choose their own diagnosis codes without coder intervention. Any thoughts on helping these providers with coding accuracy? It has to be efficient.
I actually kind of think this is perfect for IMO. This is actually, if you were to look at like something like our one of our products, or any of our products actually, but if you think about something like IMO Core Search, to your point, a provider would choose their own diagnoses that would fall into the documentation, and you would get all the beautiful codes alongside and not even have to worry about coder intervention. So I think we should probably, if you reach out, we can give you more information about those solutions that we have.
Nice. All right, for RAG, the challenge is that it does not count the synonymous. Also, the similarity scores sometimes are off due to the length difference between the embedding and the query. May you comment on this? Thank you.
Yeah, I can comment some of the details on the RAG implementations. So as Vidya pointed out, one of the strengths of the IMO terminology is we have so many more synonyms there, and a lot of them are actually the language a physician using in the clinical notes. So that provide like a difference, fundamental difference that even using the simply string-based similarity, because we have more and then closer synonyms. Usually the coverage of our code candidates, by coverage, I means if we select 20, that the 20 really have one of the 20 codes is the most accurate codes. That's the coverage of the candidates. That coverage, we evaluate that, and usually that's a pretty high in a lot of those codings. And the challenge will be how to pick the most accurate one around those top 10 or top 20. And also the embedding wise, we are training some of our like own embedding solutions using all the synonyms inside IMO terminology. The goal will be like if two terms are synonym to each other, we expect the embedding vectors to be close to each other. The semantic difference should be short enough, close enough to each other. That's also nice enhancement to this candidate generations.
Awesome. Okay, two more. How do you ensure that AI coding solutions are keeping up with the frequent updates to medical coding standards?
So on the informatics or terminology side of that equation, we're regularly monitoring and maintaining all of that coding, all those coding updates. So when I say regularly monitoring, we know when everything is getting updated or when we immediately get those files and then work on updating all of IMO's terminology to include those updates. And so all of that is actually fed into our APIs, our downstream applications, et cetera. So as my teams complete all of those updates, they should flow directly to Jing Qi's team to be able to update all of the LLMs, prompts, et cetera, and the RAG operations.
Yeah, That's true. We don't rely on like the LLM understand the most updated code because we are using those tool calls. We are using the RAG, retrieval augment generation. So as long as video provide all the most updated content, then this LLM can actually leverage and then benefits from that.
Okay, another one came in. Since it is available to add a DX, even for an abnormal reading, providers use it and we can't seem to wean, and these are not resolved either. They may not have time to resolve. I'm sorry if I butchered that at all.
Not
It
sure.
might just be more of like a comment, not a question.
Right. I mean, yeah, I think that's something that we can probably address more directly one-on-one. I think I would probably need to better understand the problem
Okay.
we're trying to solve.
Okay, we'll get back to him after. All right.
Thank you.
Final one. What safeguards do you have in place to prevent AI hallucinations in your medical coding solution?
Yeah, I think we mentioned that in the presentation that our solution is not rely on the completely the string of word generated from LLM. Actually, we are building solution on top of the solid foundation of IMO terminology. All the code we returned, that's actually the real code and then the real synonyms from IMO terminology. LLM, this role is just like a select from our terminologies, and that's fundamentally different from like you ask LLM, hey, what's the code? Then LLM just give you word by word response. That's the reason why they have hallucinations a lot. And then with our RAG and the enhancement from IMO terminologies, all the code we generate is real mega code. It may sometimes not like a 100% accurate, but those are not fake code. Those are not hallucinations.
Got it. All right, thank you. So it looks like that's all for questions. Thank you, Vidya. Thank you, Jingsu, so much for your thoughtful presentation. We're going to go ahead and close out today. Thank you all for attending. We hope you found today's webinar really useful for you. Be on the lookout for that recording and the webinar of the webinar and a certificate of attendance. If you have any information regarding IMO Health or our solutions, please contact sales@imohealth.com. Thank you so much for attending, and I hope you have a great rest of your day.
Thank you very much.
Thank you.